Your distributed system is humming. Requests flow, services respond, everything's fast. Then one service gets slow. Maybe its database is overloaded, maybe a downstream dependency is choking. It's not down, just slow. Your gateway has 100 threads. Each request to the slow service holds a thread, waiting. 50 threads stuck, 80, 90. Now there are no threads left, even for services that are perfectly healthy. One slow dependency just took down your entire API, not because it failed, because it was slow enough to consume every resource you had. Developers reach for retries first. Service B is struggling, send the request again, and again. With exponential backoff, of course, we're civilized. But retrying a struggling service is adding load to something already drowning. You're not helping it recover, you're accelerating its collapse. Resilience in distributed systems isn't about error handling or retries. It's about failure containment, deciding where failures stop spreading and how much of your system they're allowed to consume. A circuit breaker works exactly like the one in your house. When current flows normally, the breaker is closed. Requests pass through. When failures spike, too many errors, too many timeouts, the breaker trips open. Requests don't even attempt the call. They fail immediately. That's the main difference. Without it, each request waits for a timeout, 30 seconds of a thread doing nothing. With the breaker open, you fail in milliseconds. Your threads stay free. 3 states. Closed, everything normal. When failures cross a threshold, it flips to open. All calls fail fast. After a cooldown period, it moves to half open, lets one test request through. If it succeeds, back to closed. If it fails, back to open. Half open is the recovery probe. Instead of flooding a recovering service with traffic, you send a single test request. If it's healthy again, open the gates. If not, back off and wait. Circuit breaker protects your system from a failing dependency. But here's a question. What happens in those first few seconds before the breaker trips? Between when B starts failing and when the breaker opens, requests are still going through. Threads are still getting stuck. If the failure threshold is 5 requests, what if 100 requests arrived in that window? The circuit breaker stopped the bleeding, but it didn't prevent the initial hemorrhage. One slow service consumed shared resources before the breaker could react. Ships solved this problem centuries ago. A hull breach doesn't sink a ship because bulkheads, sealed walls, divide the hull into compartments. Water floods one section, the rest stay dry. The bulkhead pattern does the same thing with your resources. Instead of one shared thread pool, you isolate resources per dependency. Service B gets 20 threads, Service C gets 20, Service D gets 20. Now, when B goes slow, it can only consume its own allocation, 20 threads, not 100. Services C and D keep running because they have their own isolated pools. Requests to B beyond its allocation get rejected immediately. They don't even queue. The blast radius is contained to exactly one compartment. Circuit breaker decides when to stop calling a failing service. Bulkhead decides how much of your system a failure is allowed to consume. They solve different problems. Together, bulkhead contains the blast radius from the moment failure starts. Circuit breaker stops the bleeding once the pattern is clear. Your system degrades gracefully instead of collapsing entirely. Without protection, one failure cascades everywhere. With just a circuit breaker, the cascade stops, but there's a window where damage spreads. With both, the failure is isolated from the start, and the breaker ensures you stop wasting effort once the pattern is clear. In practice, libraries like Resilience for J give you both. Set a failure threshold and timeout for the breaker, set concurrent call limits for the bulkhead. The configuration is simple, the thinking behind it is what matters. Resilience isn't about preventing failure. In distributed systems, failure is guaranteed. It's about building walls so a fire in one room doesn't burn down the house.